Thank you and good evening. So thank you for this nice opportunity to quickly introduce our work at the Waterfront campus, and I will really keep it very brief, so don't worry. So we are here to watch this spectacular episode of Blue Planet 2 about coral reefs. So I just want to take this opportunity to bring you into the system, and here you have a view from space on the Great Barrier Reef, and this is quite often used to show how a living structure can be seen from space. But in fact, coral reefs make up only about less than 2% of the total seafloor, so it's a very small area. Yet they hold about 25% or even more of all marine biodiversity. And that shows rather dramatically how important they are for biodiversity. So they are distributed all around the globe, mostly in the equatorial regions, and many of them are located in developing nations and in nations with low income. And especially in these countries, the ecosystem services provided by the coral reefs are incredibly important. So they support overall the livelihood of about 500 million people, but in some nations, 50% of the protein supply actually comes from the reef. So they are a major source of income, for example, through tourism, and they are also the basis of cultural identity in many island nations, for example. So they are important for biomedical research, so they provide us with bioactive compounds, and I will show you a little example from our research. Overall, their global importance is as iconic ecosystems. So everybody knows about coral reefs, so they are well suited to also communicate environmental issues, and using these beautiful ecosystems can be a good way to bring this forward to the general public. So at the foundation of coral reefs are the reef corals themselves. They are animals, and they are sitting on a calcareous skeleton. And their brownish color is derived from little unicellular algae that you can see on the right upper picture that sit inside of the animal cells. So they are photosynthetic organisms, and they use sunlight to produce energy for the coral. So when the corals are stressed, this relationship breaks down, and as a result, the algal cells are lost from the coral and they turn white. So this is what is known as this infamous coral bleaching. And when the corals don't recover their algal symbionts within a relative short period of time, they become vulnerable to starvation and to disease, and eventually they will rapidly die. And as a result, the three-dimensional framework that is so important for coral reef diversity degrades very rapidly. Within a couple of years or decades, the whole structure can be gone. And this is why, unfortunately, coral reefs are considered to be among the first ecosystems that really might go extinct due to global change. But it is not only the global and climate change that affects coral reef, but it's also a lot of local stressors that contribute to the global decline of coral reefs, and that is mostly associated with the rapid growth of population, especially in coastal areas. So that leads to an increase in pollution, to nutrient enrichment of coastal waters, unsustainable fishing practice, to the introduction of invasive species, for example, the lionfish that is feeding its way through the food web of the Caribbean at the moment, and then also through careless tourism. So our work is located at the Waterfront campus, and we have the luck to have access to this nice experimental facility of the Coral Reef Laboratory. And in this experimental aquarium, we have a number of coral species that we can expose to controlled environmental conditions, so we can change environmental parameters either individually or in combination, and see how the corals respond to various forms of stress. And that allows us then to better understand how they are affected, for example, by climate change. And being at the University of Southampton, we also have then the luck to have access to a formidable infrastructure. So we have a number of collaborations, for example, with the General Hospital, with the University Hospital Southampton, where we can use their high-tech machinery to analyze our corals. And that gives us a great opportunity to understand at the molecular level what is going on. So one of the areas where we were active are the fluorescence of corals, and you can see here a fluorescent brain coral, and we've been working on them for more than a decade, and we have discovered a number of important insights, how they function for the corals, how they protect them from excess sunlight, but also how they provide an optimized light field for corals in greater water depth. And this particular brain coral yielded a green fluorescent protein that turns red when you shine a pulse of UV light on it. And that makes it very useful as marker in biotech applications. And in fact, Eric Betzig used it to invent his concept of super resolution microscopy, for which he was awarded the Nobel Prize in Chemistry in 2014. So this is a nice example how these bioactive compounds out of reef organisms can really help research, and especially medical research. So we are using the Persian Gulf as a natural laboratory. So you can see here the map of the Gulf, and this is a temperature map. And in the southern parts of the Gulf, you have the hottest reef environments of the world. So temperatures go up to 35 degrees on a regular basis in summer, and still you have corals growing there. And so we want to understand what allows them to grow under these brutal conditions, and part of our work was then to study the algal species, and we discovered that many of them have a new and distinct species of algal cells, and that was discovered here in Southampton, and we named it Symbiodinium thermophyllum. And finally, a large project which went on for 5 years now was dedicated to study the effects of nutrient enrichment, and we found that unfavorable nutrient environments can in fact increase the susceptibility of corals to bleach. But that in turn also shows that it's very important to keep the water quality at the best possible level, because that will allow then the corals to take on a little bit more heat. So that has implication obviously for policy development, and this is why we are collaborating with governmental organizations together with our public policy unit at the university to convey this message to policymakers. And we've run recently a workshop with an environmental governmental agency in Abu Dhabi, where we gave lectures to them and discussed opportunities, how they can improve the water qualities to render the reefs more tolerant to stress. So last but not least, we are communicating this also to our students, and my colleague, Dr. D'Angelo, has actually started now a new module. This will run next semester, and we are directly communicating the findings of our research in this module. So with that, I'm at the end of my brief introduction. I want to thank the funders of our work. I thank you for coming, and we are all looking forward to this, what is surely be a spectacular episode. And if you have some questions, I will be here after the screening, and then I would suggest we have a little discussion afterwards, but now we should not wait any longer and switch to the screening.